Well, thank you. Thank you for having me. Thank you for attending as well. I'm going to talk about the medium voltage grid automation. I'm especially using the IEEE 1901/2020 standard that has been widely discussed already. I hope you already picked the key technical information. Just a little word about myself. I'm Philippe Comte. I'm product manager and application engineer at GE Grid Solutions. I'm based in France. I have 20 years of experience in PLC in general, and I'm part of the critical infrastructure communication group. So just one word about us, because you probably know GE, but maybe you're not familiar with the telecom business of GE. We are operating globally. We have our dedication is to serve our like the GE customers, industrial customers that not only need automation systems, but also the telecommunication part of it. So we are designing products and solutions in home, dedicated to those critical applications. So not only like regular hardware with long-lasting products, but also reliable software, including the cybersecurity part that is very much talk these days. We are, as I said, operating globally, and we have 3 headquarters in Vancouver, Canada, in Rochester, New York, and in France, Paris. That's where I'm sitting. And we are developing products around, let's say, 3 main transmission technologies, which are fiber optics, wireless, and PLC. Regarding verticals, so I say we serve industries. The main one, as part of GE Grid Solutions, we mainly focus on the grid power utilities, both on the transmission segment, but also the distribution segment, so medium voltage and low voltage. One of our key products is the Orbit platform that you see on the left-hand side. That's a wireless platform. So we are very strong on wireless for this segment. But we also we're kind of agnostic to the technology. We're trying to find the one that really suits the best all the applications. And we've had a long-term interest in BPL. So I'm going to talk about especially the BPL application for medium voltage grid automation. So for those of you who are not familiar with it, what is the medium voltage distribution grid look like? You have primary stations that are delivering the power from high voltage to medium voltage, and then you have some lines, and of course, everyone knows that it's a mix between overhead and underground installations. The location where you have the transformers and switch gears and closers and all the DMV equipment can be sitting on the pole, can be inside cabins, can be manholes, basements, you name it. So from there you can already think that there's this is already a call for a variety of communication means. In terms of topology, you have either redundant topologies. You can have rings, so an MV cable that comes from one primary station, goes around and comes back to the same, or you can have some sort of backfeed between 2 primary stations. So wherever you are connected to the grid, you always have a backup cable, so you can be powered at any time. So if there's something wrong on one cable, then the power can come back from the other side. There are still some a lot of places without redundancy. Usually it's more rural areas where it's usually overhead, and it's more simple. It's more a radial architecture. And if I talk about if we talk about the distances, I mean, some people will argue, but I won't argue on this. I think typical distances for me are around 50 meters to 1 kilometer in dense areas. There are plenty of definitions, so don't quote me on this. But this is just to give you an idea of the very common range in dense areas. But when you go outside dense areas, you need to go much further. So 10 kilometers is something that you can find. Yeah, there's even more, but let's say that with 10 kilometers target, at least you can probably cover the majority of the cases. And about dense areas, again, even though the typical distance is limited to maybe less than 1 kilometer, what happens very often is that the very first stop between the primary station and the first secondary substation is pretty long. So you don't want to live in the neighborhood of a primary station. It's a big yard with HV lines. It's not very friendly. So usually those primary stations are sitting at the outskirts of the town. So the first hop to the primary, the first secondary substation is a bit longer. So that's also is kind of a hurdle for the communication when you're using a broadband power line. So what do we need to do? What's the objective when we want to connect those locations? We need to bring several types of traffics. There's a bit of monitoring. So you have a fault detection on medium voltage. You have the switchgear status. You want to measure voltage, current, power, whatever. You want to connect meters. You want to monitor the transformer as well. You can also do control. So you can control the switchgears remotely. So you can really operate the grid, and you can open, close some points. You can open the loops, the rings, and you can isolate some chunks of line so you can work on it. These are the things that are done mostly manually, but if we had the communication, we could do it more often from a remote place. And then there are many other applications that you could think of that are related to those locations, especially the main substations. You need to control the access. You need to verify that there's nothing wrong inside, like flooding, gas leakage, or whatever. Then you have also everything that belongs to low voltage that is sitting on the side of the medium voltage network. So probably you want to monitor the LV side of it. And maybe you have also some AMI network that requires a data concentrator that maybe is sitting in this specific location that will also benefit from, let's say, an uplink through the medium voltage. So those are all the services you can think of, and I'm probably not exhaustive here, but you can think about several applications and several IEDs that are sitting in the same place and needs to have a communication uplink to across to the servers across, let's say, a BPL ring or BPL network with made of several hubs, and then through the core network of the power utility. So what are the key requirements? I'm just focusing on performance here because for the purpose of that presentation. Of course, there are many others. I'm not talking about cybersecurity, but that's a key part of it as well. But for performance, we always focus so much on throughput and latency. Actually, what is needed today is not high bandwidth. It's not super broadband. Usually, those automation traffics, they are pretty low. Maybe with only 200 kilobits per second per location, you can do all of this, or you can do most of it, let's say. The only thing is that because you're aggregated so many traffics from so many different places to one, then in the end it becomes what I would call broadband. So that's why we need a broadband power line communication solution. And if you think about typical size of a network with 5 to 20 nodes, 1 to 5 megabits per second throughput is something probably reachable. So you need to at least to provide this. Then if you think about latency as well, that's been spoken a lot, especially in the days where we were trying to do internet access and voice over IP and that kind of thing. I mean, today the SCADA systems are not so so complicated for this. If we take away the protection systems, which are very automatic and autonomous and very quick, all that is related to monitoring and even control, they don't require such a low latency. So let's say 100 milliseconds is a good figure. It's all acceptable. So imagine that you have like 10 hops on your network. If you have 10 milliseconds per hop, that's good. You're good. So all in all, the throughput and latency is not really a big constraint compared to what we've done for many years in BPL. We were targeting, as JP showed you before, 200 megabits per second data rate. That's even too much for what we are trying to achieve. So what I was missing is really coverage and stability and availability. Those are the two key things that we need to work on. First, coverage. You had a good idea of the distances, but think that sometimes you don't even want to cover all the nodes, all the locations at once. Maybe there are places that you can't access, so it's not very easy to get in, or it's not worth putting some equipment in it. So if you want to bypass those locations, it adds up some distance. So in that case, you really need the long haul transmission systems. And also by default, let's say what you want is to have something that is very reliable. So from day one, when you plan your network, you don't want to face the risk of having one link that doesn't work, and then have to redesign the whole thing. And if you think about the ring, if there's one link that is missing, then you lose the complete ring, and it's not appropriate. So we really have to focus on long haul, on distance and coverage, and make sure that this is really we have some good margins, so we can the system can operate everywhere, to the compromise of throughput and latency if necessary. But coverage is a key thing. Then it's also about stability and availability. And if you think about some of the applications, especially the control applications, they are the most demanding. So imagine you want to control the switch gears. If something happens on the power line, I mean, we are sharing the fate with the power grid. So if let's say a cable is cut and the signal doesn't go through, then we need to find a way to recover from that. So that can be done in different ways. You can use a mix of technologies, and I'm going to show that a little bit later. But you can also use the redundancy, the intrinsic redundancy of the grid to achieve this. And also without reconfiguration, I mean, you need to have a high resilience to noise, and in order to avoid the performance to drop, you want to commission your system and have a very stable data rate and something that lasts for a long time. So why broadband PLC? For those applications, I mean, those are three very obvious points. But broadband, as I said, you need to support multiple real-time applications. So I told you a few megabits per second throughput. Then it needs to be cost efficient. That's the number one thing people think when they are thinking about the BPL. No heavy works, no tower, no big investment. You can pay as you grow, as I used to say. You start small and then you progressively extend your network. Then you need to have a private system, so you can control everything, availability, coverage, QoS. If it's a private network, it's all controlled, and that's something we are always advocating for as GE, serving our customers. We are really focusing on private solutions. One of the major competitor, I don't like to see it like this, but because as GE, we're a huge promoter as well of wireless, and especially private LTE. One of the things that sometimes that is kind of overlooked with private LTE is some blind spots in the coverage, and also some problems with availability when something happens. Sometimes the link is not as reliable, and that's Tom was mentioning for Wi-Fi. The same thing can happen with LTE. So here I have two cases where the complementarity could really show. there's the case where you want to extend the coverage to some blind spots of the LTE network using BPLC. And there are places where you have two LTE communications, but for availability sake, you want to backfeed them. So you can use BPLC like that. It's two complementary technologies. What were the roadblocks so far? We had some issues. I will focus only on the first part, which is the technology definition. For a long time, we have used the UPA technology, the good old UPA, as I would call it, but that was lacking recognition. There was no, it was not the international standard. There was no more use cases. The ecosystem was too small. It was pretty difficult. So it was, technically speaking, close to the solution, but not enough to really be a success. And on the opposite, as JP has described, the industry was so focused on high speed that the only first standards that came out were only focusing on 200, 500 megabit per second, something like this. And that was not applicable for medium voltage, for the reason that I already told you. There were some other problems due to implementation, but one of them being using the wrong standard, trying to use the wrong standard that didn't have the coverage, so that made some projects to fail, and build up some bad reputation to for the technology on the way. There were many things that I hope today we can recover from by using the right technology and the right standards. So back to the positive point, we're very happy to have this IEEE 1901/2020 standard and implemented into the HD-PLC 4th generation. I won't go into much details. We already had plenty before with the other presenters. The first point is the long haul capability. That's really key. The second point was the higher noise immunity, especially. This is something that wasn't discussed, but there's a better immunity against some of the most common noises on the line, which are periodic and synchronous to the power cycle. So this is something that is pretty well handled now with let's say the modern technologies. Then the MAC layer is also improved, and that helps making the frequency planning simpler and having more cost-effective solution. You can mitigate interferences between parts of the networks. So this is really key to the system. And then thanks to the CSMR routing, the new multi-hop capability of the HD-PLC, where you can have a control latency and you can have fast rerouting. So all in all, the fast rerouting plus let's say an instant association time or very quick association time, that really helps to build some resilient architectures. I will finish by telling a little bit about what's going on. So last year we had a very strong relationship with Panasonic. So we started to build a strong relationship with Panasonic on this HD-PLC 4th generation. We, together with a European power utility that is very experienced in this area, we made a trial, and that utility is actually already using quite a lot of BPL, only UPA, but they were looking for for an alternative and a more modern solution in order to extend the existing network and also get a foot into the low voltage. So they were seeking an equal performance on medium voltage because they already have engineering rules. They know how it works. They know what to expect from BPL, so we couldn't show less. And they wanted us to demonstrate that on LV it would solve some of the key issues they had, especially related to coverage. And then the third point was also how all of this, medium voltage plus low voltage would coexist, because they had rules to roll out medium voltage, but then adding some networks on the low voltage side would create some interferences. So they wanted to know exactly how this would be handled. So we had to demonstrate all of this. We did some lab testing, we did some field testing based on early prototypes of that fourth generation, and then we tried it. And the good thing is that we were very successful. So, everything was passed at first attempt. We showed equal performance, more or less, with the medium voltage on the medium voltage, because we were using exactly the same engineering rules. I bet that if we had the chance to change a little bit, we could be a little bit better, but at least they were happy with the result. On LV, the plug test was 100% successful. We managed to do all the links that previously had failed with other technologies and vendors. And in the lab, we demonstrated some key aspects about resilience and interference mitigation, topology management, all things that they were not necessarily expecting, but are really a plus coming with along with the HD-PLC fourth generation. So of course, the IEEE 1901/2020 was crucial to make this happen, and that our utility is now considering to start rolling out this technology, the HD-PLC fourth generation, as soon as we are able to deliver the first equipment. So as GE, we're really involved in this process. We are very happy, and we are very happy to promote this solution at a global scale. We think, even though we keep being a strong promoter of wireless technologies and fiber and everything that is fitting, I think that DPL, especially HD-PLC, is taking part now of the portfolio of the applicable solutions for our customers. And I thank you for your attention.